so many different definitions about digital twin. So what we're thinking about is really not what we're talking about today is not connect the digital twin of the part or the building or whatever. It's really the data what we're connecting through our design and design for manufacturing process, through manufacturing, and how we loop that back for making better decisions. But if we're talking about digital twins, first of all, we need to digitize our shop floors. Right? That's how we experience that shop floors really look like. Right? We have this upfront process, doing really good CAD and CAM processes, have everything digitized, and as soon as we are making money with it, we are printing paper. Right? And then we're processing that paper through the factories, through the shop floors, organizing it on the left-hand side. These are all customer examples, right? For logistics, we have all paperworks and setup sheets and everything is sticking somehow to the machines. The problem with that is it's completely inflexible. As soon as we have a change, we're running around the shop floor and finding the paper and doing something with it, doing redlining, getting feedback on the paper. That never gets back to the design environment or the engineering department for making it right the next time. So how can we solve that? What we have introduced earlier this year is a solution what we call Fusion Production, and we're taking care about this workflow. Traditionally we took care about design and CAM on the left hand side, but now you can get out of your CAM environment all the data directly in a solution, cloud-based, in real time updated down to the shop floor. We're creating work instructions, scheduling, tracking, getting the reports, and most important, that's the digital twin, the connectivity to the digital twin, getting the data feedback to all decision makers for different purposes. So how we are doing that, and this is a short overview video, right? You're all familiar with this process, getting the program designed for manufacturing process done, but then you push a button on the right hand side, you're getting all the information in there. It's connected already to your machines on the shop floor. You feed all the information, pictures, drawings, cheat codes, all the data what you need as contextual data to the shop travelers in a digital way. And we save it, we annotate it, we get basically all the informations digitized to the operators. We dispatch it, we flag it as a hot job potentially. Right, everything is a hot job. Only the manager is allowed to flag it as a hot job. We machine it, we're simulating it, we're getting mobile clients, all the informations what are around there, what we traditionally put on paper, we're getting with mobile clients, what everybody has with it, into this kind of system. And then we are able to connect the machines to this information, and we can, on a time base, in real time, analyze what's happening actually on the machine. Not what we have planned, what actually happened there. You can set it in maintenance mode, you can set it on program. We're scheduling it, we're rescheduling it. At the millisecond you're making a change here to the schedule, everybody who's using the mobile client get informed about that. So it's all actually data. So no running around, no paper, no lack of information for decision-making processes. So the tracking piece is also an important information, right? If you're only using traditional machine monitoring solutions, you will get the machine data, but the contextual data from your operators are missing. So what we introduced here is a native application on mobile clients that you get all these informations by video, by voiceover, by text, whatever you want to use into the system so that it's related to this job, to the digitized workflow. The machine data, I'm pointing on this directly again, is important to get this in a granular area into the system because we can later making better decisions on the holistic overview of that. Right? For the operator, it's important how I'm getting this machine up and running, how I utilize this bit of asset in my shop floor in the best way. But on a holistic perspective, I want to know where I'm losing money, where I'm losing capacity, where I'm having my downtimes. And that's what we can do with this kind of reports more on the management level, where we have a holistic perspective on that. This is a typical dashboard what you can have on the machine. With this data, you see immediately in real time what's happening on the machine, and then you get something like a diagram for spindle speed, spindle loads, into this area as well, so that you get rid of the peaks in the spindle speed, that you overall can accelerate the machine in a better way. What we're working on is then something like that, right? Traditional data feedback on paper, that's what's happening execution time. Now we're expecting that this job is done pretty soon, and what happens is, oh shit, this job is taking much longer than we're expecting. On the lower feedback loop side is what we're doing there is that we're getting immediately, when we're starting a job, the information, this job will take much longer than we have expected with the simulation or with our experience. Right, if I'm going back to the situation, as soon as you're starting a job, you will get the predictive time. So that's a prototype what we're having running in our facility in the AMF, what we will bring to the product. This is a what we call dynamic rescheduling piece. So we know exactly that this machine will be occupied much longer than we thought, so we can reschedule all jobs what are planned to be on that machine later on up front, and not at the point in time when we are expecting to start the next job. And then digital twin on a holistic perspective, what we are able with the solution is getting contextual data into the systems as well. So with this kind of solution, you can get your facility with the geometry in there. We have all the machine data in there, and what we're doing then is really getting into the details. So you have the context, visual, and then you get the data from the machine. But not only from the machine, we're also getting data from environmental data. Humidity, is this window open or closed? What is the spindle speed, the spindle load at that point in time at this particular machine? In context of the contextual data, you can solve a quality problem. I like this example because this machine is close to a door. It's behind that dashboard at the moment. And when we got into this use case, we found out that they had a quality issue, but there was no patterns behind the quality issue. The surface was not okay, the tolerances were not okay. So everybody was trying to solve this issue. Nobody recognized that every point in time when they had this quality issue, this door was open. So temperature dropping, humidity has impacted this high precision part. So when I was running an industrial engineering department in a company, we were running around for 6 weeks minimum to get all this data together. And if we were lucky, we got to the point that this is the pattern where we had the quality issue. If you have that in real time at hand, you can go to your date timestamp basically and say, okay, what happened exactly at this point in time on the machine, outside of the machine, with the quality, with the material. All the data are in real time prepared to dig into that and making decisions. And this is the net profit from having a digitized version of the shop floor. First of all, we're digitizing it to make it more transparent, to execute in a better way, to have all information at hand on the shop floor. But in long term, we could put machine learning algorithms behind that so that we find data, and then we can expose it in the engineering environment, designed for manufacturing environment, to make better decisions in the first place. Yeah, so this was a really short and quick example of how we're doing that. We're using this solution in the advanced manufacturing facility in Birmingham to really improve it and learn from it. Yeah, but also happy to get involved with all the projects, what you're doing, and exploring how digitized manufacturing, digital twins and connectivity could help you improve your business. Yeah, and last but not least, I would recommend that if we're thinking about digital twins, we're thinking about what does a digital twin for us mean and how is this related to our business models. Because a digital twin is not a digital twin. We really need to think about what could we get out of it and what is suitable for our shop floor, and not searching for one solution and then adopting everything to this one solution, really going in there. And that's the reason why we built Fusion Production on a platform what we call Forge, so that we can hook up different partners and enriching this data and not having one solution fits all. It's really customizable and easy to manage for every different shop.